Hello geometry students, welcome to the continuing series of videos on theorems about parallel lines and transversals. And in this video we are going to prove the alternate interior angles theorem, part 1, in other words the forward direction. If you don't remember, look back on the previous page. And let's look back together. Alternate interior angles theorem, that's this one, part 1, that says if the lines are parallel, then the alternate interior angles are congruent. And the if part is always the given, or the start, and the then here is the conclusion, or the way that we finish. So in this picture, we're going to use the same thing. We're going to be given that line 1 is parallel to line 2, and we need to end with angle, let's say angle 4 is congruent to, what did I do over here? 1, 2, 3, 4. Oh, I have these two backwards. 1, 2, 3, 4, 5, 6, 7, 8. So angle 4 and angle 6 are congruent. Okay, and I have this box here so that we can maybe list out some useful ideas. So right off the bat, I'm going to write vertical angles because this is just something that comes up very frequently. And maybe we can use the substitution property. We could also use the transitive property. And most importantly, we're going to have to use the corresponding angles theorem. We're going to have to use this one. This is an important one, and we can't really prove a whole lot without it. Okay. And this says that if two lines are parallel, then the corresponding angles are congruent. And you don't always have to make this box. You can just kind of go at it, but it's good to see so that to jot down some ideas that we can probably use later. Okay, so you can also see what makes this proof a little bit difficult is that you have a statement that starts with something being parallel and an ending point with two angles being congruent. Usually in geometry, at least up to this point, we really haven't done anything like that. We usually start out with something about angles and we finish in the same way. But here's for the first time something slightly different. So let's get to it. So I know then that because the two lines are parallel, angles 1 and angle, let's not use 1, or I suppose we can. Let's see. I can see that angle 1 and angle 5 have to be congruent to each other. I'm sorry, I changed my mind, and I want to explain why. So I can say that angles 2 and 6 are congruent to each other because of the corresponding angles theorem. And I should number these rules. Number 1, rule 2, rule 3 here. So by rule 3, okay, that's true. And let me explain why I chose to go this route. Instead of using 1 and 5, I use 2 and 6 because 6 is in our finishing step. So we want to use a choice here that will get us closer to that finishing step. So now if I look at this, I have 2 and 6, and in the final solution I have 4 and 6. So if somehow I can find a way to connect 2 and 4, that would be really nice. And in fact I do. If you look at 2 and 4, those are vertical angles. So they must be congruent. And now I'm basically done. 2 is equal to 6, 2 is equal to 4, therefore 6 must be equal to 4. Okay. And the reason here is the transitive property. Ooh, I forgot to number, I didn't number it in here, so I'll just call that rule number 4. It's a little bit out of order there, but it still gets the job done. Okay, so there we have it, a very simple 3-step proof that goes from two parallel lines to two congruent angles. Now I'm going to deliberately skip this next part for now. Maybe come back to it a little bit later, so that you can see, you can practice this. Just try this on your own. Okay, I'll post the final solutions, but you should really try it on your own and see if you can get it done by yourself. Thank you for watching. There's some more videos coming along here, and have a wonderful day.